In this video, I'd like to talk about the really common networking architecture called peer-to-peer. Peer-to-peer, which is different than client-to-server architecture, is one where there are only peers connecting to each other, or only clients connecting to one another. So the diagram for a game might look something like this. If we had 4 players all playing a racing game, there'd be no server in this model. There'd just be the 4 clients, the 4 players, on their own machines, and they would all have direct connections to one another. This is a little bit different than client to server, where you only have connections to a centralized server. In a model like this, one of the benefits is, well, you can send messages directly to one another, right? This client over here could send a message directly to this client over here. One way to think about it is, if you were building a chat system, you could have sort of your global chat where it goes to everyone and you broadcast out those messages. You send 3 messages. Or you could have individual whispers and you could send it to individual clients, right? Now, this isn't exactly how chat and whisper is implemented, but you could implement it this way, right? The important thing is to note is that you can send messages, whether those are data or remote procedure calls or object synchronizations. You can send those directly to individual clients and directly to individual clients as opposed to needing to send them to some centralized server first, right? One of the other benefits of not having a central server like this is there's no cost to you as the developer. You make this game, you make this application, you put it out there and launch it on Steam or Epic Game Store, and everyone downloads and buys this thing, and that's it. They can connect to each other and they can play and have a great time. With the client-server model, you need to maintain those servers. You need to pay for those to be in a data center somewhere or stand those servers up. And so there's a cost associated with that. The second thing is, at some point with all client-server games, the servers will stop being supported. And we always hear about games where the servers are shutting down, and so you can no longer play that game anymore. Well, that doesn't really happen with peer-to-peer. With peer-to-peer, there's no servers to shut down. So clients can continue playing this game, and people can keep playing this game, effectively forever. One of the downsides, though, is that all the code that you write for your game is sent to every single client. It's all in one bundled application. So if you ever have something where you want your clients to be able to save information in some backend database or do something else that you would imagine that only a server would typically do, there's really no way to do that. Every single one of the clients can all do the same stuff, right? So there's no way to separate that logic. Every single client has all the logic that a server would be doing for your game, as well as the logic of what a client would be doing. The next tricky thing with peer-to-peer like this is sort of who acts as the authority, who's in control of deciding which actions actually take place in the game, or what the real state of the simulation is. If this is a racing game, and just due to network latency, we're both racing or all 4 players are racing, they're all about to cross a finish line, one of these clients is going to cross first. Or all these clients cross first. And it looks like, on my own computer, it looks like I won. And on your computer, it looks like you won. And that's just because of network latency that's going on. So one of these clients is going to have to act as the authority for this game. Really commonly what happens is one client is sort of selected to be the host, right? Let's say it's this one. How do games decide which client's the host? I don't know. A lot of times it's whoever started the lobby first, whoever sent the invites. So it's kind of random on who this host is going to be. And you can also, one thing that's really important is, like, this host may need to be the person who has the best internet connection so they can send the most frequent updates and send the most frequent messages. So sometimes you'll have games where people debate on who should be hosting the game. Now, the benefit of being the host is you are the authority on what's going on inside this game. So when all 4 of these players cross the finish line at the same time, well, it looks like you won to you. So you're just going to tell everyone else that you won, right? And that's what's going to happen. We hear this phrase of like host advantage thrown around quite a bit. And what that is essentially putting a name to this phenomenon that because one of these clients is also acting as the authority on the simulation, what they see and how this player interacts with the game tends to be more true than how the rest of the clients who are all playing and interacting with this game. So this client tends to have a better experience in general. One of the other downsides to peer-to-peer is that connecting these clients together can be somewhat tricky sometimes. Most of us have cable modems at home with built-in firewalls that are blocking all of our individual ports and not allowing incoming connections. And when this client over here sends out invites, they need to be able to allow the rest of these clients to connect to them. They need to be able to establish these connections. Well, for the most part, firewalls allow outgoing connections, but they don't allow incoming connections. That's the type of internet traffic that they're blocking. So you may run into an issue, or you may start needing to explore something called network address translation, or NAT punch through is one thing that's typically called, which is how is it that we allow these things to connect to each other? The second thing that may end up happening is, well, the person who's acting as your host may need to open up their firewall settings. And we have also probably all experienced games like this where you need to open up the settings for your firewall, enable something called port forwarding that forwards specific ports to your computer on your network so that all these other clients can connect to it. So there's a lot of pros and a lot of cons to doing peer-to-peer versus doing client and server. The decision on which model you go with, or if there's some sort of mixture between that you go with, is completely up to us as developers. We may decide that peer-to-peer is the best option for this game because we don't need an authoritative server. It's a nice casual game where we're playing together as friends. Or we may have a highly competitive first-person shooter where we absolutely need that centralized authoritative server. Or we may be building an MMO where we need to have this connection to some backend databases and backend services that we don't want all the clients to have connections to. In which case, we're sort of, the decision to go to a client server model would essentially be a no-brainer, right? These types of decisions are incredibly important to us as developers. There are games that have launched and have flopped because they chose to do a peer-to-peer model over a client-server model. Why did they try to do that? Well, it could be because of studio costs, of server costs, right? We didn't want to have to support servers. And so we saw that it was a more cost-effective model to do peer-to-peer, and because of that, we launched using a peer-to-peer model. Grand Theft Auto Online is largely peer-to-peer, and what do we see? We see a lot of cheating. We see a lot of people spawning tanks in the middle of the road where they shouldn't be, generating money. And with a model like this, who is it that's in control of the game? This host? This one client here, potentially? What makes you think that this client wouldn't be the one hacker? What makes you think that this client would be the honest one? Sometimes, when you're playing a peer-to-peer game, this host will be the one who's cheating. And now they are the authority of the game, and they're cheating. They're the ones telling you exactly how the game is behaving, and they're providing basically a poor gameplay experience for everyone else. So there's a lot of important decisions here, that sometimes can be influenced by the business models of your games, and sometimes can be influenced by you as a developer. So that's why it's really important to know the ins and outs of these various models, peer-to-peer versus client-server, or some sort of mix in between, and always being able to assess these and pick which option is best for the game that you're developing.